This is a worked solution to AQA Physics P2 June 2013 higher tier paper question 4. This question is about stopping distance of vehicles. The first part, what is meant by thinking distance? We have to learn that thinking distance is the distance travelled by the vehicle while the driver is reacting. A really common misconception here is to write something about it's the time taken for the driver to react, because people get it confused with reaction time. It is not that, and you wouldn't get marks for writing that. Two factors that affect thinking distance. Well, there are numerous factors we can include. Tiredness and drinking alcohol are two, but others you could have would be taking drugs, the speed the car is travelling at, or perhaps distractions such as using a mobile phone. Be specific about those though. Question 4b tells us a car is travelling at a speed of 20 meters per second when the driver applies the brakes. The car decelerates at a constant rate and stops. The mass of the car and driver is 1,600 kilogram. And we need to calculate the kinetic energy. So the kinetic energy equation is that kinetic energy is equal to a half times mass times the speed of the vehicle squared. So in this case it's a half times the 1,600 times 20 squared, and that calculation should give us 320,000 joules. 4b part 2, how much work is done by the braking force to stop the car and driver, relies on you knowing that energy is converted from one form to another. So in this case, the kinetic energy the car had, 320,000 joules, must be equal to the work done in stopping the car, because if it had that much kinetic energy and then lost that much kinetic energy, that must be the energy converted by the brakes. Then goes on to ask us to calculate the distance travelled by the car while braking, and it tells us a braking force. We know the energy that was converted by the brakes, so that's the work done by the brakes, and we know the force. A formula that links work done, force and distance is that work done is equal to force times distance. So in this case the work done was 320,000 joules, the work done by the brakes. The force of the brakes was 8,000 newtons, and that is then multiplied by the distance, which gives us distance is equal to 320,000 divided by 8,000, which is 40 meters. 4b part 4 tells us the braking distance of the car depends on the speed and the force applied. State one other factor that affects the distance. Well, you could write down anything from icy wet roads, worn tyres, the road surface, the mass of the car, because a heavier car has a greater braking distance, or the efficiency or condition of the brakes. So any of those will do, but I'm going to choose icy or wet roads. Applying the brakes causes the temperature to increase because the work done by friction between the brakes and the wheel causes a decrease in kinetic energy and an increase in thermal energy of the brakes. So it's about energy conversion from, kinetic energy to heat energy. C relies on us to focus on the first part of the sentence that hybrid cars have an electric engine and a petrol engine. When the charge of the electric engine runs out, then the petrol engine kicks in and takes over. So if the car is fitted with a regenerative braking system which slows the car down and generates more charge, it means that using one, the advantage of using one would mean that you would have to charge the battery less often. So that would increase the range of the car in the electric engine mode. The reason it does this is it increases the efficiency of the car. Because less energy is wasted. As the decrease in kinetic energy is no longer just lost as heat, but converted to electrical energy